Hi! So today I made a ping pong game without using any rigid body, kinematic body or any of that physics system stuff. All I used was the Area 2D and raycasting. The Raycast 2D does most of the heavy lifting here. So let me just show you how I made this. First of all, simply nerf the left and right wall. These ones. They are kill zones. If the ball touches these, it gets reset back here to the center and gains a random velocity in some direction. Then we have these ones, the top and the bottom wall. They are ordinary walls. The ball is going to be reflected off them at the same angle it went in. The ball itself, of course, it has a raycast attached to it. It can use this raycast to figure out if there is a wall or something ahead of it. The two pedals. They use the same script, the pedal script, and I have a little variable here that can tell me if it's the left pedal or the right one. Each pedal has a raycast going down and one going up, just so I can see if I'm colliding with the wall, so the pedals don't move beyond that. Now let's take a look at the pedal script first. Since they're the same, all I'm really doing is comparing what input action I want to use. So the down and up action are different for left and right. And yeah, currently it's basically a two-player game controlled via the keyboard. It's simple enough to add an AI to this, but for the time being I just didn't bother. So there's no game AI, there's just two players on the keyboard. And other than that, I predefined a speed, and that's about it. For the actual movement, well, I'm just checking the y-axis first to make sure, is there any movement using the input? And if there is, put it in the y part of our vector 2. The x part always remains 0 because we're not moving in the x direction with our pedals. Multiplied by speed, multiplied by deltas for each frame, and the movement is properly scaled. Then, based on which direction I'm moving in, I can use my raycast with the same vector that I'm trying to move in. So the raycast is set with cast 2 and it gains the same vector. So if we go here, if we look at this up ray, this is going to be just as long as I'm trying to move up at any time. This could potentially cause issues if there's massive lag, but most of the time it should work fine, and it should trigger as soon as you get too close to this wall, and then just refuse to move. If it's fine, if there isn't a collision, we can move upwards or downwards depending on which direction we're using right now. And that's pretty much all there is about the pedals. The only other thing we have is the ball. The pedals do have groups, just to make sure to mark them as a pedal. This helps out for the ball here. The ball only has one raycast, it's just going to be moved into whichever direction which we're currently moving. So again, we do have a base velocity and a speed. The velocity is random generated at first, so if we just go in here, the randomized velocity function, it's a random vector 2, essentially, that is normalized and then multiplied with speed. It also can't be the vector 2.0, because if it ever remains the vector 2.0, it's just getting randomized again in the physics process. Just in case. Though it would be very unlikely to actually get this outcome. Wouldn't want the issue where the ball very rarely just stops moving. Other than that, whenever the ray that is currently pointing at stuff, we're casting the ray in the same place we are trying to move, based on our velocity times delta. If that is colliding, we can check for what we are colliding with and where we are colliding. Get the distance that is covered by moving to there, and how much is remaining if we want to move on afterwards. And yeah, then essentially we just want to calculate how our movement is. This you could actually, I think I'm not using it here anymore. I changed this code at some point. So I can actually put this here. And I think that doesn't change anything, yeah. So one case is if we are colliding with a pedal. If so, we just check for the center point of the pedal and basically make the vector that points towards the collision point here, from the center of the pedal towards the collision point. That's our new direction. Then we multiply that by speed and we have our velocity, and we can move. Then for the other case, where we say that we are colliding with a wall instead of a paddle, we can just say, well, we can just get the walls normal at the collision point and then bounce off it. The bounce is a vector2 function, so we don't actually have to do any other work manually here. The vector2 already has that implemented. So then we adjust our velocity and our position, and that's it. Now one last thing we have here is this on ball area entered. Because our ball is an area 2D, and the only thing the area 2D really checks is if it collides with these things at the side. I'm not using the Raycast for that, because I wanted to make sure it actually touches and stuff. Just in case the arrow gets too long at any point, the vector gets too long, I would like to make sure the ball only hits it when it actually is touching right now. If the ball gets somewhere here, it could still be recoverable. Let's see. Yeah, that's pretty much what it's like. I can still recover it if it's down there. Since my direction goes from the center of the pedal, if the ball goes past the center, it's going to be reflected backwards, so it's no longer recoverable. Bit hard to show that, but yeah, that's how it works. This is how we're using the pedals. We can also roughly tell where the ball should go. Wait. I'll make it steeper. So yeah, that's how you can make Pong without really using the physics engine at all. It's not perfect, but it's a pretty fun and actually quite performant way to do this, so why not? Plus, since everything is drawn, I don't even need any graphics, since I can just use the debug mode visible collision shapes to see what's going on. Nice. That will be all for today. Bye.